Process exercise. After successfully completing this exercise, you will be able to understand the basic process used when modeling sheet metal designs in Creo Parametric, create a primary planar wall feature to use as the base feature for a sheet metal design, create secondary flat wall and flange wall features, create notch and form features, create a flat pattern for a sheet metal design, create a drawing to detail both the formed and flat patterns of sheet metal design, create a bend order table and add it to a drawing along with associative notes, and create automatic ordinate dimensions for the flat pattern of a sheet metal design. In this task, we create a new Creo Parametric sheet metal model. In the ribbon, click New from the Data group. Type Enclosure in the name field. Select Sheet Metal as the subtype in the dialog box. Clear the Use Default Template checkbox and click OK. Select the MMNS Part Sheet Metal template and click OK to create the new part. Enable only the following datum display types. Point display. In this task, we create a primary planar wall 200 mm by 100 mm by 0.5 mm thick. In the ribbon, click Planar from the Shapes group. Select Datum Plane Top from the model tree as the sketching plane. Right-click and select Corner Rectangle. Sketch and dimension a rectangle as shown. Click OK. In the dashboard for the planar wall, type 0.50 in the thickness field and click Complete Feature. In this task, we create a secondary flat wall with a trapezoidal shape. In the ribbon, click Flat from the Shapes group. Zoom in and select the lower edge on the right side of the model as the reference for the flat wall. In the dashboard, select Trapezoid from the Shape drop-down list to override the default of Rectangle. Double-click the wall height dimension. Then type 50 and press Enter. Note, alternatively, you can drag the drag handle to a height of 50. In the radius field, type 2.0 and press Enter. The model should now appear as shown. Click Complete Feature from the dashboard. In this task, we create a secondary flange wall with an L profile. In the ribbon, click Flange from the Shapes group. Zoom in and select the lower edge on the front of the model as the reference for the flat wall. Press Shift and select the surface as shown to select the surface loop. The surface loop appears as shown. In the dashboard, edit the radius to 5.0 and press Enter. Double-click the wall height dimension, then type 50 and press Enter. Click Complete Feature from the dashboard. From the InGraphics toolbar, click Corner Relief Notes and Bend Notes to disable their display. In this task, we create points and pattern them to use as references for notch features. Rotate the model approximately as shown in the figure. In the ribbon, click the Datum Group drop-down menu and select Point. Select the surface as shown. Right-click and select Offset References. Press Ctrl and select datum planes top and front from the model tree as the offset references. Double-click the vertical dimension, then type 20.0 and press Enter. Double-click the horizontal dimension, then type 25.0 and press Enter. Click OK in the Datum Point dialog box. Press Ctrl D to orient to the standard orientation. With Datum Point PNT 0 still selected, right-click and select Pattern. Select the 25 dimension and press Enter to accept the default value of 25.00. Type 3 as a number of pattern members in the first direction, and click Complete Feature from the Pattern dashboard. In this task, we create 3 sheet metal notch features using the points you created in the previous task as references. In the ribbon, click the Engineering Group drop-down menu and select Punch. Select Circ Notch 20 mm W tabs.gph and click Open. Verify that the Advanced Reference Configuration checkbox is selected and click OK in the Insert User-Defined Feature dialog box. In the User-Defined Feature Placement dialog box, notice that the first surface reference is selected. And select Datum Plane Right from the model tree. Select the second surface reference and select the front datum plane from the model tree. Select the point reference and select Datum Point PNT 0 from the model. Select the Adjustments tab. Select Direction Extrude 1 and click Flip. Click Accept Settings. Right-click Group Circ Notch 20 mm W tabs in the model tree and select Pattern. Click Complete Feature from the Pattern dashboard to create a reference pattern. In this task, we create a sheet metal punch form feature. In the ribbon, select Punch Form from the Form Types drop-down menu in the Engineering group. Click Open Punch Model from the dashboard. Select Boss Form.prt and click Open. Select the Options tab in the dashboard. Click in the Excluded Punch Model Surfaces collector. Press Ctrl and select the 3 surfaces as shown. Select the Placement tab. Select Coincident from the Constraint Type drop-down menu and select the first reference from the form model. Select the second reference from the sheet metal model. Click Plane Display to enable their display. Click New Constraint from the Placement tab. Select Coincident as the constraint type. Select the front datum plane from the form model and the top plane from the sheet metal model. And click Flip. Click New Constraint from the Placement tab. Select Distance as the constraint type. Select the right datum plane from the form model and the right datum plane from the sheet metal model. Click Plane Display and Point Display to disable their display. Double-click the offset dimension, type 30, and press Enter. Click Complete Feature from the dashboard. In this task, we create a flat pattern of the model to use later in a drawing. In the ribbon, select Flat Pattern from the Flat Pattern Types drop-down menu in the Bends group. Click Complete Feature from the dashboard. Note: the Form feature was flattened automatically, because in the Options tab, the Flatten Forms checkbox is selected. In the model tree, select Flat Pattern 1. Right-click and select Edit Definition. In the dashboard, select the Options tab and clear the Flatten Forms checkbox. Click Complete Feature. Note: the Form feature is now not flattened. In the model tree, select Flat Pattern 1, then right-click and select Edit Definition. In the dashboard, select the Options tab and select the Flatten Forms checkbox. Click Complete Feature. In this task, we create a bend order table. In the model tree, select Flat Pattern 1, then right-click and select Delete. And click OK in the Delete dialog box. Click the Bends Group drop-down menu and select Bend Order. When prompted to select a bend to add to the current sequence, select the bend surface on the left end of the model as shown. When prompted to select a bend to add to the current sequence, select the bend surface toward the back of the model as shown. When prompted to select a bend to add to the current sequence, select the bend surface near the front of the model as shown. When prompted to select a bend to add to the current sequence, select the bend surface on the right end of the model as shown. Review the finished bend order table. When you are finished reviewing the bend order table, click OK to close the dialog box. Click Save from the Quick Access toolbar and click OK to save the model. Click Close from the Quick Access toolbar. In this task, we begin creating a new drawing to document the formed and flat pattern for the enclosure.prt. In the ribbon, click New from the data group. Select Drawing as the type in the dialog box. enclosure underscore C underscore DRW in the name field. Click OK. The new drawing dialog box appears. Notice the default template is set to C Drawing. Click Browse in the template area of the dialog box. Note, there are two Browse buttons in this dialog box. You need to click the lower one in the template section. In the Open dialog box, select PTC C Drawing.drw and click Open. Click OK in the new Drawing dialog box to create the drawing. Note, the drawing is populated with views and dimensions. In a production drawing, the next step would be to clean up the placement of the dimensions and add any other drawing elements needed to document the model. Since this is just an educational example, you can leave the sheet as is and move on to the next task. In this task, we continue the drawing creation process by adding a second sheet to document the flat pattern of the model. Click New Sheet from the document group. Click Drawing Models for the Model Views group. Click Add Model from the Menu Manager. Select Enclosure Flat1.prt in the Open dialog box and click Open. Right-click anywhere in the display area and select Insert General View. Select No Combined State and click OK in the Select Combined State dialog box. Click in the center of the drawing to place the view. In the Drawing View dialog box, select the top model view name. Click Apply. In the Drawing View dialog box, select the Scale category. Select Custom Scale and type 1.75 as the custom scale. Click Apply. In the Drawing View dialog box, select the View Display category. Edit the display style to No Hidden. Click OK to complete the drawing view. In this task, we add the bend order table, bend notes, and auto ordinate dimensions to the drawing. In the ribbon, select the Annotate tab. With the view still selected, click Show Model Annotations from the Annotations group. Select the Datums tab in the Show Model Annotations dialog box. Click Select All to select all the datum axes. Note the appearance of the bend axes for each of the bends. Select the Note tab in the Show Model Annotations dialog box. Click Select All. Click OK. Click in the background to deselect all geometry. Note: the bend notes are associative. The note leader for each is attached to the corresponding bend axis for each bend. Select Auto Ordinate Dimension from the Ordinate Dimension Types drop-down menu in the Annotations group. When prompted to select one or more surfaces for ordinate dimension creation, click to create a box and drag it around all of the surfaces in the drawing view as shown. Click OK in the Select dialog box. Click select Baseline from the Menu Manager, and select the far left edge of the model's geometry as shown. Note the resulting ordinate dimensions. Click Select Baseline from the Menu Manager, and select the bottommost edge of the model's geometry as shown. Click Done Return from the Menu Manager. Note: in a production drawing, the next step would be to clean up the resultant ordinate dimensions and keep only the ones you need to document the model. However, it is generally more convenient to have Creo Parametric create the ordinate dimensions for you, and then to delete the ones you do not want, as opposed to creating each of the ones you do want individually. In this task, we save the models and erase them from memory. Click Regenerate from the Quick Access toolbar. Click Save from the Quick Access toolbar, and click OK to save the model. Click Close from the Quick Access toolbar. Click Erase Not Displayed from the Data group. Click OK to erase all objects from memory. This completes the demonstration.